The solar system is on a journey so massive, so fast, and so mysterious that most people have no idea it's even happening. We're not just orbiting the sun, we're racing through the Milky Way at breathtaking speeds, spiraling like a cosmic arrow cutting through space. This video dives into the stunning truth behind that motion, how the planets follow the sun in a dynamic helical path, why the sun takes 225 million years to complete one galactic orbit, and where we are heading right now. By the end, you'll understand the hidden movement shaping our entire cosmic neighborhood. Most of us imagine the planets orbiting the sun on a flat, circular racetrack. But the real motion is far more dramatic. The sun is constantly moving around the Milky Way, and the planets aren't simply circling it, they're being pulled behind it in twisting, corkscrew-like spirals. This is known as the helical model of solar system motion, and it completely changes how we visualize our place in the galaxy. As the sun travels at about 220 kilometers per second, it creates a sweeping forward motion that forces every planet, from tiny Mercury to distant Neptune, to follow behind it like a group of dancers orbiting a moving stage. This turns their paths into 3D spirals rather than flat loops. Every orbit Earth makes around the sun every year is actually a looped step taken within a much larger galactic journey. This spiraling motion doesn't just look beautiful. It reflects the gravitational balance that keeps the solar system stable while moving through interstellar space. And it's only the first layer of this incredible journey. To understand the full picture, we need to zoom out even further and follow the sun's enormous orbit around the heart of the Milky Way. If you think Earth moves fast, wait until you see the sun's pace. Our star is completing a gigantic orbit around the center of the Milky Way, a trip that takes roughly 225 to 250 million years. Scientists call this a galactic year, and humans have only existed for a tiny fraction of one. Since the dinosaurs disappeared, the sun hasn't even made half an orbit. This motion places the solar system on a curved path around the galaxy's core, guided by gravitational influences from billions of stars, dark matter, and the supermassive black hole, Sagittarius A star. The sun's journey isn't a perfect circle either. It gently bobs up and down through the galactic plane, like a ship gliding over cosmic waves. This subtle vertical motion affects how we interact with interstellar material as we travel through the galaxy. The speed is astonishing, nearly 500,000 miles per hour, or about 220 kilometers per second. Yet we never feel it because everything around us, planets, moons, comets, and dust, moves together as one giant gravitational family. But what exactly are we moving toward? The next section explains the direction of our journey and the cosmic environment we're traveling through right now. Every journey has a destination, and ours is toward a point in space called the solar apex. This is the direction the sun is moving through the Milky Way, located in the region of the constellation Hercules, not far from the bright star Vega. It acts like the solar system's forward direction, revealing the path we're carving through the galaxy right now. As we push toward the solar apex, we're moving through a region of interstellar space, known as the Local Interstellar Cloud, a wispy, low-density region of gas stretching about 30 light-years across. The Heliosphere, a protective bubble formed by the solar wind, shields us as we pass through this environment. NASA's Voyager 1 and Voyager 2 spacecraft have helped map this boundary, confirming where the solar influence ends and the galaxy truly begins. This forward motion also shapes the heliosphere itself. As the sun moves, the heliosphere stretches into a teardrop-like structure with a compressed front and a trailing tail. Understanding this environment is crucial because the interstellar clouds we encounter can influence radiation exposure, cosmic particle density, and even the long-term stability of the heliosphere as we journey across the galaxy. The solar system's movement is far more dynamic than the simple textbook model we grew up with. We're spiraling through space, racing around the Milky Way, and traveling toward the solar apex while shielded by the heliosphere. These discoveries don't just reshape how we imagine our place in the universe, they highlight the scale, speed, and beauty of our cosmic journey. Understanding this motion helps scientists track interstellar changes, study the heliosphere, and explore the future path of our star system. If you found this journey fascinating, make sure to explore more Space iNews episodes and join us for the next adventure.